We're going to, come on, join me, my friend. Okay, so say we have y equals 3x squared plus 6x minus 2. And I ask you to complete the squares. And I'm Mrs. Lepp, and I was tired the week before we left. I told you to put the brackets in the right spot for the So we're going to put the brackets in the right spot. So what are we going to do when we complete the square? What's our first step? Is to take out the 3. Now the 3 has to distribute through, right? So we shouldn't put the bracket in front of the 3. We should put the bracket behind the 3. But I put the bracket in front of the 3 because I'm a dummy. So we're going to go 3. And I don't know why I do that, because what I always have taught is you go 3 and then you go bracket, bracket, always. So you take the number out and then you bracket, bracket. So what's our first bracket look like? Square or round? Opposite of that, square. So we're going to go square and then we're going to go round. Now the round is what gets us the perfect trinomial square, right? And then the square bracket is what gets us to distribute the 3 through. So that's why the bracket should be here and not in front of it, because that's just done. So we go 3, bracket, bracket. That 3 comes out of how many? The first, how many? The first and the second. It comes out of the first 2, right? So we take a 3 out of 3x squared, and we're left with a x squared, which is what we need, because we need a 1 in front of that baby, right? That's what our goal is. And then when we take the 3 out of the 6x, what are we left with? 2x. And then we have to put a what? A plus? Blank. Round bracket? Minus blank. So do you see why the square bracket has to be here instead of in front, which is why I was putting it like a dummy? Because this square bracket makes you remember to actually distribute it. Right? If the square bracket's in front, it would only distribute to the round one, which makes no sense. All right? So if you go number, square bracket, round bracket, onwards, right? Does that make sense? So the square bracket causes you to distribute, the round bracket causes you to have a perfect trinomial square. Make sense? So take out number, bracket, bracket, then carry on with what we did before. And then at the back, we just have this little homie sitting back here, minus 2, right? Just hanging out by itself till the very end. How do we get those blanks? B divided by 2, and then square it. So the blank is b divided by 2 squared. And what's b? 2. It's always the one beside the x after we've taken out the GCF, right? So it's going to be 2 divided by 2 squared, which is 1 squared, which is 1. And I don't skip this step, correct? Even though it looks easy, I don't skip it because it's my look back. It's the one that I can look back at. Right? So I'm going to get adding 1 and a minusing 1. So now in my next step, I can actually drop off the square bracket because I'm going to remember to distribute it. And that's the only reason why I have the square bracket. We agree? So I can write the 3. This turns into a perfect trinomial square. What multiplies to give me 1 and adds to give me 2? X plus 1 and x plus 1, right? And if I forget, I can always go back here and take what this is. It's a plus 1. And remember when we use the b, we always use whatever the sign is. So this was a plus 2, so I use a plus 2 here. But if this was a minus 2x, I would use a minus 2x. Correct?
Yes.
So we're going to get x plus 1. And we have to remember to put a squared. And then the reason why we have the square brackets is we have to remember to distribute, which gets us a minus 3. And then the negative 2, the homie's back, can now join it. Right? So we get y equals 3, x plus 1 squared minus 5. Now let's go through a few little things. What's the vertex? Remember? Use your brains. Go back 10 days. What's the vertex?
-1 and -5.
Yes. Opposite of this, David? Same as this, right? So -1 and -5. Exactly what you were thinking, correct? Okay. Is this baby concave up or concave down? It's concave up because we have a positive 3 and a positive 3, correct? Our leading coefficient tells us. So we know it's concave up. If it's concave up, does it have a max or a min? min, because concave up looks like this. So it would have a minimum. What is the minimum value? Y equals what? What's the lowest this goes to?
-5.
-5, because my vertex is -1 and -5, right? So this one is a minimum at -5. What's my y-intercept? Which form is helpful to get my y-intercept? Yeah. The first one. It's -2. Yeah. This one here gets me my vertex form, it gets me my vertex, gets me my concavity, correct? This one up here is helpful because this gets me that it's concave up, it gets me that it's a minimum, and then this back here is always my y-intercept. It's nice and quick, correct? So it's at 0 and -2. What's my domain? X such that an element of the reals, because with the quadratic it goes on forever, right? Up or down. It's like tough guy or up. Praise the Lord. Right? Goes on forever. XER, XER. We agree? Now, unless it's a word problem, which we haven't had to do till today. Range. Y such that. This is a minimum. We know this. We know our minimum is at -5 or what? Greater. So my range is going to be y such that y is greater than or equal to -5 YER. We agree? Do you see all those things I made you do for this one? What do you think I'm going to make you do now? Another one on your own. Yay! Oh, you're so excited. Good. Great. You all look like you don't want to be here. I don't believe that because it's super fantastic to be here. So I don't get it. I don't get it. So we get y equals -2x squared minus 6x minus 1. Made them all negative because that's what you guys all look like. Negative Nellies. So you're going to give me that in what form? Vertex form by doing what? If I want it in vertex form, what am I asking you to do? Complete the square. And I want the vertex, concavity, y-intercept, maximum value, domain range. Okay? And go. So I set you up for one that's a bit harder. So we go -2, we write the number, then bracket, bracket, right? Number, bracket, bracket. If you do that, life will be good. Always square bracket, round bracket. Take the -2 out, we're left with 1x squared, which we have to be. If we're not left with positive 1x squared, we messed up, because that is what you need to GCF out to be left with, right? -6 divided by -2 is positive 3x, plus blank, round bracket, minus blank, square bracket, only at the back. Now I set you up, because I set you up with a b that doesn't divide by 2, right? I set you up with a b that's an odd number. So my blank is going to be 3 divided by 2 squared, which if I square these, I square the top and the bottom, I get 9/4. Right? And then the one back is literally what b was. Right? Now, some of you may have turned it into decimals, but I'd rather keep it a fraction until today where there's word problems. So most of you complain about word problems, but word problems, you actually turn these into decimals. So, this is good, right? Right? It makes up for the word problem. So we get 9/4, 9/4. So we're going to get y equals -2 bracket x, and then I look one back, plus 3/2. If you put 1.5, you're fine. I just wanted you to freak out a little bit. So 1.5, is 1.5 the same as 3/2? Yes, it's totally fine as long as it is not rounded. So like 3/2 turns to 1.5. They are the same thing, right? But if you have 1/3, which is 0.33333333, and you write 0.33, that's not actually 1/3. It's a different number. So if the decimal terminates, you can write it. If the decimal repeats, you have to leave it as a fraction, because 0.33 is not 1/3. They're not the same thing. Okay? And then we get -2 times -9/4 is positive 9/2 minus 1. So you could have had 4.5 there. It's the same thing. And you get negative 2x plus, I forgot the square, 3 over 2 squared, plus 7 over 2. So you could have that, or you could have had y equals negative 2x plus 1.5 squared plus 3.5. You have those? Either one's fine, because both of them are terminating decimals, right? So if you put the decimals, you would have been just fine. I wouldn't have done anything to you. All right. So my vertex is at what? Let's do it from this one. What's my vertex at? Negative 3 over 2. Take the opposite of this, and positive 7 over 2. So you could have had negative 3 over 2 and 7 over 2, or you could have given me negative 1.5 and 3.5, and I would accept both. Right? Is it a max or a min, Anna?
Maximum.
Because it's
Concave down.
it's concave down. So it's a maximum at what?
Y equals 7 over 2.
Y equals 7 over 2. Or we could have wrote y equals 3.5, and Mrs. Lepp would have been happy with either, right? A little happier with the fraction, but I'd be still happy with the decimal. Okay? My domain. Kylie. What's my domain?
X such that X is an element.
And what's my range?
Y such that Y is
Yep, because I'm going downwards, right? Less than what?
3.5.
3.5. Less than or equal to 3.5. And it's equal to because it actually equals that value, right? Or I would have been happy with y such that y is less than or equal to 7 over 2. Both of these are the same thing, and I'd have to accept either. All right? Did I ask for anything else? Oh, my y-intercept. Other Kylie. Kylie E. What's my y-intercept at? Yeah. So it's always this one here, which is 0 and negative 1. And now I'm going to ask one that I didn't ask about. Joy, let's see if you remember, because I'm throwing you right for a loop, not even warning you and not giving you any time on this. Axis of symmetry. So I'm basically a jerk. It's x equals what?
Axis of symmetry, X equals
Negative 1.5. See? You got it. So I could have said negative 1.5 or negative 3 over 2. You got it. See, 10 days and brain's still there. Didn't trust your brain, but it was there. All right? Can you guys open up your notes to word problems? These bad boys. Here.
So we need to make sure we're on the problem solving page, example number 1, maximum area problem. Okay, is everyone good to go? I'm going to go by the method of 2 thumbs up. Are we all good to go? No? Okay, I'll give you a moment.
Set.
Amelia, do you know where you're at? Do you have the notes at least?
Yeah.
Okay.
Just can't find it. I know, it's fine. I don't think this is even a unit.
Okay, let's get started, everybody. Okay, so we have a problem that says a rancher has 100 meters of fencing available to build a rectangular corral around the side of a barn. So right away, as soon as you get a word problem like this that deals with perimeter or area, we want to draw out the scenario because seeing this visually is going to help us a lot. So right away, I'm going to say, let's make the rectangle they're talking about. And then let's label this one side as the corral that it's up against, right? Because they're saying we're building it up against the side of the barn here. So we'll label that C. Then we have a width, and then a length. Okay, so we have all our sides labeled here. We're going to have our 2 widths, our corral against the wall. So that one, we're just going to kind of label as a unique side. You can put a little scribble through it. You can do whatever you want. Just make it unique in some way. And then you want to label your bottom as the length here. Okay, So in this case, we want to write a quadratic function in standard form to represent the area of the corral. So in these types of problems, we need two things right away. So once we have our diagram, our second step is going to be, well, what's the perimeter of here? What's the available dimensions for the fencing? So we're going to say P is equal to, and what is this equal to? Well, we have two widths that are available for the fencing plus the length. And we're not counting that corral, right? Because that's up against a building. We're not putting fencing along that. We're going to ignore that. What about our area in this case? What is our area equal to? Joy, what would our area equal to in this case? Exactly, because we just want a standard area of a rectangle. So we're going to say width times length. Okay, so now we have our diagram and our two components, but we wanted the area in terms of a standard form, right? So what we're going to do is we're going to use our perimeter equation so that we can solve for this in just one variable. So let's put in, we know that the rancher has 100 meters of fencing available for that. So we know that the perimeter can be a maximum of 100 in this case. So we'll say 100 is equal to 2W plus length. And now if we want to substitute a variable into the area so that we can build this equation, let's isolate the one that's up by itself already. So in this case, we're going to say length is equal to, and we'll subtract 2W from both sides. So we have this equation. Now we've subtracted, so it's going to be 100 minus 2W. Okay, so now we have a length here. But remember, we want the equation in terms of the area. So at this point, we're going to substitute this length value in for the length up in the area formula. So it's going to be W times 100 minus 2W. We're going to distribute that right because we want to put in the W for both of those terms. So now our area becomes A is equal to 100W minus 2W squared, because W times 100 and then W times the negative 2W, so negative 2W. So we have our equation now. And do we recognize how that's in standard form? What's the only component we're missing in this case? Specifically, what does a standard form look like? Can anyone tell me what that looks like? Anna, what does a standard equation look like? If I was to write it out off to the side here, what would I write? Y is equal to?
2W squared plus negative 2W squared.
Yeah.
Plus 100W and then plus Y.
Exactly. And so that was that missing component I'm talking about. In this case, we just don't have a constant value. But do you guys see how it looks the same? And you can actually just even rearrange it so that it looks more familiar for you. That's a great idea. And then, so now in our next one, we've fulfilled the A, so we write a quadratic in terms of the standard form to represent this area. But now what we want to do is they say, what are the coordinates of the vertex, and what does this vertex represent? So how are we going to get the vertex from this equation? Yes, exactly. So what would be my first step here? What I'm going to do is just rewrite out the same equation. And actually, I'm gonna do what we did off to the right there and actually just reorder, because that's gonna be our best step here. So we're gonna say that the area is equal to negative 2W squared plus 100W. Okay, and from our previous examples that we just worked on at the start of class, Luke, what's gonna be our first step here? You got this, I believe. We want to set up our vertex equation from those last two examples. And so what was our first step? Well, it is in standard form. Yeah, we want vertex form. So what can I do to this to set up those brackets that we need to do, aka put into vertex form? What am I going to write? Yes. Square bracket, yes. Yes, round bracket. W squared. And then what does this term become if I factor out a negative 2 from it? It's going to be a negative 50, right? Because if we have negative 2 times negative 50, we get 100 back. W. And then we want to do plus bracket minus bracket, and then this one should be squared on the end there. Okay, so now we need to solve for whatever's in those blanks here. So what does our blank equal to? Our blank is equal to negative 50 divided by 2 squared, which is equal to negative 25 squared. And then what's 25 squared? Can someone do that in their calculator for me? 25 squared. 625. Okay. Got you. Okay, so we're going to substitute that in for this line here now. So we have is equal to negative 2 square bracket, round bracket, w squared minus 50w, and then plus our 625, bracket minus 625, and then square bracket. Okay, so we're almost there. So now what's our final step here? What are we going to do to make this like transform into our final step of our vertex form? What do we have to do? Christian, what do you think we have to do to this?
Simplify it.
Yes?
I don't even know.
It's okay. If we do this, remember, we have the perfect square set up now. So if we say negative 2 bracket, and then with our perfect square, what term do we write in there?
It would be the negative 25.
Exactly. It's the one that was from our square. So you're good to go there. Remember, we always have to write squared. So negative 2 bracket w minus 25 squared. Then what happens to our constant term here? When we have it in the brackets and distribute, now what does our end term become? So when I do this, 2 times this one, and then remove it outside the brackets, what does it become?
Yeah.
Yes, David. Either one. 1,250. Positive 1,250. Okay. So in this case, now what does our vertex represent? If we're putting it in terms of P and Q, what does this look like? That's where you can answer, Christian.
So the P would be negative 25.
Remember, what is it always?
Oh,
If
it becomes the opposite.
opposite sign, yeah. 25 and 1,250. Okay. Now the question says, what does this vertex represent in this equation? Well, what were they asking for originally in the question? They said, we want to set up this equation such that we're making the area. And so if we know that this is symbolic of the area, what's the y value in this case? Or like, what's this q value represent?
What does your Q always represent? Your Y, but what?
Well, maybe this would help too.
Max, he's got it.
Yeah, exactly. Because what's the direction of opening in this case? What's the sign of our A value? It's negative, right? So we have a graph that looks like this. So we know we have a maximum at that point. So in this case, we say that 1,205 is the maximum area. So I kind of don't have a lot of room here. Can we extend any more on the side? No, I don't think so. Okay, well. So our maximum area is equal to that 1,250. The units, yes. What were our units from above here? What did we have? What do we have to pay attention to with the units? What are we in? Like
Meters.
meters, exactly. It's right from the problem. You'll never have to guess with that because they'll tell you meters or centimeters or whatever it is. So in this case, we have 1,250 meters and squared, right? Because we're talking about an area. If it was just the length or the width, then we would just say meters. But we have a square unit because it's the actual area itself. Any questions with that word problem there?
You do dimensions too.
Good idea. Because we'll actually need that for the next part here. So in the case of our dimensions, what is this 25 actually symbolic of?
What letters was it?
That is true. But yeah, what letter is with it? what is x in this case? If we're solving this like a typical equation, what's x in our, like we have, what's the comparable of x in this case?
W.
W, exactly. And what did we say W was from above? We actually said that that was our width. So if we want to just solve for our length at this point, we can actually put it into either one of these because we know actually both of these equations. So for this case, let's just solve it in for our perimeters. So we said that a maximum perimeter can be 100. It's equal to, well, what is W? It was our 25, right? And then in this case, we have an L. So now L is equal to 100 minus 50, because that comes from our 2 times 25 and moving it to the other side. So we get a length is equal to 50. 50 meters, yes. And what is my width equal to? Ooh. Do you say 25?
Yeah.
That's right, yes. And so what that actually means too is that we said that that's going to equate to the maximum area, but that's also the maximum in regards to what the width can be and what the length can be for that specific combination to give that area. So if you were to adjust these lengths or widths at all, that's going to give you some area that's lower and wouldn't equal. So this is the only spot where you're going to get that specific maximum area is having those dimensions as they are.
You can check them offline. Right? If you do 50 times 25, what do you get? 1,250, which is the max area, right?
Yeah.
So when you go down to the equation, I always underline, if you look at that W minus 25 and use a different color, I underline the W minus 25 because that's going to either get you the width or the length, and in this case it got you the width because we used what variable? W, but had we isolated for L, and those were L's, it would have gave us the length, and the back number I always circle because it always gives me my max or min, right? And in this case, the equation that you guys are doing was area. So you can see your max area, right?
And just to reiterate that point, like Ms. Lepp was saying, in the beginning, we could actually choose to do either variable. So that was why circling these and highlighting these in the end are really important, because we could have just isolated for L in this case, or in W in this case, which would have looked a little bit different on our equation. We would have just had L's instead, and then it would have solved a little bit differently, but you get the exact same values for that. So it is really important to recognize what variables you have here, because that tells you a lot about what's going on. Let's, for this next one, it's going to be a very similar problem here. So what I want to do is actually solve for the reverse variable of whatever it is. So in this case, it says that at a children's festival, there's organizers are roping off a rectangular area for stroller parking along the side of a building. So very similar to last problem. We have a rectangle against the side of a building. So let's draw that out here. So we can draw a rectangle like that. I'm just going to label the top one again the wall. So I'm just going to put little dashes through it and call this the wall. Actually, that's going to get confusing. I'm having W there. I will label it just like, let's say it's a stroller parking, so we'll just label it P. Again, we have the width, we have a length, and another width.
Why did you pick the sides as the width?
Technically, you could go either way. So Ms. Lepp was basically saying that why did I choose to put width here and then length here? Because technically we could do this instead. We could say the lengths are here and the width is here. But I guess that's just a matter of orientation. So if we know that, depending on the way you're going to look at this, you can kind of just choose it either way.
You're going to have to pick the widths on the sides because you want to make a max area. You want those to be widths, right? Because you want to make a maximum area. So you want the side length that is not going to be fenced to be your biggest side. So you don't have to fence it.
Yes. Cross.
Do you know what I mean? You want to make a maximum area. So you want the side that you're not fencing to take up the most amount of length as possible.
Ah, yes, yeah.
Yeah, you know that.
Straight, yes, okay.
Totally. Because you've taught me.
Okay, so with this one, what we're going to do now is that we're going to do the exact same setup as before, but this time they say instead of the 100 meters we have 160 meters of rope available. So in this case, let's write out our perimeter equation again. So our perimeter is equal to 2W plus L, just like it was before. The area is going to be equal to length times width, just as before. But then what did I have to do after I set this up? So now I have my rectangle, I have my two equations. What can I do to this now if we want a quadratic that is in terms of area? What was my first step here? Hannah, do you know what we're supposed to do here? So in this case, remember, we want to use these equations to blend into one, but because we have the two variables here, we're going to use the perimeter equation to assist us in making this just one equation. So in this case, we know our perimeter is 160 meters, or that's the amount that's available. So let's say 160 is equal to 2W plus length. Okay, so now remember, it's easiest to isolate the one that's just by itself in this case. So we can say length is equal to 160, and since we subtract the 2W off both sides, that means our new equation is minus 2W. So now we can take this bit of information and sub it in for our area equation, which means that we say area is equal to length was 160 minus 2W times W. And then what does this equal when I distribute it? Anthony, what is this going to look like when I distribute it?
160W.
Yes?
And
Negative 2W squared, exactly. And so we know that this is equal to the area, but for the sake of last problem too, what I'm going to do is actually just reorder this. So I'm going to say area is equal to negative 2W squared plus 160W. And that's going to be the area equation they're looking for. And yet again, the only thing we're missing is that constant term, but because of the way these problems are, you're not going to have that constant term at the end. But this is what our general form is that represents that area. In the next one, we have a very similar solution here. It says, what are the coordinates of the vertex? So what do we have to do in this case? Riley, what are we going to do in this case? Kylie. Riley's not here. Kylie. Yeah, vertex. So what is this going to look like? We have area is equal to negative 2. What does our setup look like? Yes? Yes? And then when we take a 2 off the 160, what does that become? Yeah, negative 80, exactly, because you're just dividing it by 2, right? Plus, minus, and then our square bracket. So now we just have to solve for whatever's in those blanks. So we know that our blank is equal to that negative 80, our middle term, divided by 2 squared, which is equal to negative 40 squared. And then what's 40 squared? Type that into your calculator quick, and then I'll ask one here. 1,600? Is that right?
Yeah.
Yes, it is. Perfect. So now what am I going to plug into my blanks here? So I have negative 2, square bracket, round bracket, W squared minus 80. What term do I add here? Joy, what am I going to add here? That's, oh yeah. Sorry, I'm overthinking that. Okay, there we go. Perfect. And then to simplify this, what are we going to put? So we have -2 bracket W. What term do I put in with our perfect square? Joy, I'll ask you again because you knew the last one. Yeah, exactly. That -40 is the term we're going to put in there. So we say -40 squared. And then what's our constant term? What do we have to do first? Anna, what do we have to do here?
We have to distribute the -2 and the -16.
Yeah, and then so what does that become? What is our constant term?
3,200.
Plus 3,200. Awesome. And then similarly, it says, what does the vertex represent in this case? So what does our vertex represent? Kylie, what does this represent?
The vertex represents.
What did you say it represents?
Like the area.
Yeah, exactly. Well, partially of it. So we have our P and our Q, right? And if our P and Q is representative of 40, because opposite side of that one, and then 3,200 here. Kylie was saying, well, that 3,200 is going to represent our maximum area. So we know that our maximum area,
And then the 40 would represent.
yeah, that the 40 is the width, exactly, Kylie. So we say our width is equal to 40 in that case. But if we want to sub for our length here too, how do we get our length from this?
We substitute the width in the formula.
Yeah, and which one do you want to do? Do you want to put it in for the area or for the perimeter equation? Sure, let's do that. So we'll say 160 is equal to 2 times 40 plus length. So what does my length equal to in this case? 80, exactly, because we're going to have 160 minus this term here, which is 80, which then just leaves us with 80 for the length. So we have both our width, length, and the maximum area, which is represented all from information we get from the vertex here. What is our domain and range? What I want you guys to do is put this in for your calculator, and then give me a range and a domain that is determined from that. So everyone enter this equation, the vertex equation, into your calculator under Y1. To reiterate this point, so we have 40, which is our axis of symmetry, so that's right in the middle of the parabola. So we know that we can also use our 3,200 as our y value. So let's put our y's from 0 to 3,400, and then our x values from 0 to 80, just so we have a complete picture of what our parabola looks like.
Then I have to repeat myself to get real angry.
So with this one, the reason we want to go from 0 to those values, or from 0 to 80 and then 0 to 3,400, is that we know we can have a negative area or a negative length, right? There's no such thing as like a negative length. We don't go -4 meters back unless we're talking about directional stuff. But in this case, we're talking about actually building materials. There's no such thing as a negative building material or a negative area. So they always have to be positive values. That's why you're only going to see a picture that's within the first quadrant, because there's no chance that this would be negative. And specifically, we don't want to take any values that are negative, because having a -5 width makes no sense. What I want you guys to do is when we have our units here, or when we have our width and our length, we want to make sure we include units. So width is going to be in meters, remember, because the problem lists meters. And then same thing for our length, 80 meters and 40 meters for that. And then for our maximum area, we remember how it has to be meters squared. So if you forgot those units or you didn't put them in like I did, just always go back and throw them in like that. What's our domain and our range based on what you see from the graph? Christian, were you able to get a domain for that?
Not yet.
Amelia? No?
You're just finding the other x-intercept, right?
Yes, Tyler.
For, like, the domain and range, I got x such that x is an element of the range, and then for the range, I got y such that y is less than 3.
So you got y such that,
Y is less than or equal to 3.
so you're saying partial parts of them. The only reason that I'm going to object to these is I'm going to explain why these are what they are. Joy, did you have an answer?
It's because it's area and can have a negative area.
Exactly. So what do these have to be? How am I going to write these?
It'll be a y such that
A.
sorry,
Yeah. You're right.
area.
Right. A. Your variable for y is A. You're right.
So the range would be
Well, if we have to account for that it has to be greater than or equal to 0, how are we going to write that?
a slash z that y a is greater than or equal to 0.
Yeah, and basically, like, the way that I'm looking for it is this. So we know that it has to be between those values where y is an element of the reals.
A. She's just saying A slash because you
Yes.
start off with
Because you have
A.
to write the beginning of the
Yeah.
A is an element of the reals.
And then you
Perfect.
put an A at the front. A was the straight down line. Very front, very front. Keep going, keep going. After the bracket, before the 0. Use the A and the straight up and down line. You know that.
Yes. Oh,
It just threw you off because it's an A.
I'm just going to erase those because that's going to be confusing. So A such that A less than 3200, where A is an element of the reals. Right, because we can't go below the y-axis, right? There's no such thing as negative area, and as soon as we go below the x-axis, we start going into negatives, so we can't do that. Same thing with the domain, actually. So we can't go past the y-axis, because if we see this pictorially, we have a parabola that looks something like this, right? And if we know that area is represented here, right? And we know that our width was represented by our x-axis, no such thing as a negative. So we can't go negative width or negative area. So it has to be that width such that 0 is less than or equal to width, which is less than or equal to, and then in this case, what was our x-intercept on this far side? Tyler, were you able to get that part?
No, but I think it would have been 2.
Exactly. And that logic is actually really good because we know that if that 40 represents the axis of symmetry, that's actually just the midpoint line. So we have 40 here, 80 here, and then 0 here. They're all just 40 increments, right? Because that's the midpoint. So we know it's just 40 on both sides. So even without even using your calculator, you could just say, well, I know exactly what that x-intercept is. And then vice versa. You could also say, if I know that's the midpoint, then 0 has to be to the left of it. And then, yeah, pretty much as long as you're writing them like these, you're good. We just have to make sure that you're accounting for the fact that they have to be greater than 0 because we don't have negative areas or lengths. Any questions with these questions here? Yes, David.
So you always fill in the range in the domain like this if you're like dealing with area?
Yes, so it has to match up to whatever your variables are, and more specifically, yes, if we're dealing with area, you're always going to have a format generally like this, because, yeah, you're never going to have a 0 value for them. So, or a negative value, I should say. You can have 0, just not a negative. So, yeah, it's very much going to look like this pretty much every time. And just make sure you're using the right variables. So, in this case, if we're using A's for Y and then W's for X's, make sure that that matches up in your domain and range. Because if you do what I almost did and put it in an X or Y, then your marker is confused because they're not really seeing what's going on, and they don't know what's equal to X or Y unless you specifically list it.
Yeah.
Any questions before we move on to the next one here? Yes, Amelia. Yes. I will get you guys to work on 1, 3, and 4. So just circle those ones. Those ones are going to be the ones that are very similar to these, and I'm just going to walk around and help you guys for a bit here. And this is from your word problems handout on page 14.
Certainly have that on page 14 of the text, so it sounds like you the textbook memorized? Good on you, I don't know how to pause. Go like, if you get something like this, if you're given something like this, right?
But they're all equal.
This is what? That's my length, right? And what is this? And.
So it's 4 widths.
But like a quick.
So what's our perimeter?
They're all equal size, or just question specific.
It's 4 widths plus 2 lengths. That's how it is.
But could you not just subtract this?
You just read that. You just.
Why not?
You'll have to put fence there.
You're calculating for this thing.
Oh, now you say
That's the
it's.
question I was asking.
Yeah, but it can also ask for dimensions.
They want to ask for dimensions later.
No.
I want you guys to pause on the practice problems. We're going to continue into revenue problems. So it's the second type of problem we're going to be dealing with. They look a little bit different. The setup's a little bit different, but the end result's very similar for the most part. So in this case, they say a student council at a high school is planning a fundraiser activity with a professional photographer taking portraits of the individuals or groups. The student council gets to charge and keep a session fee for each individual or group photo session. Last year they charged $10 for a session fee and 400 sessions were booked. In considering what price they should charge this year, the student council members estimate that for every $1 price increase, they'll get 20 fewer sessions booked. So right away, we get a massive paragraph. That can be overwhelming. But what we want to look at is we have dollars and dollars, and then we have quantity and quantity. So in this case, what's going to be their total revenue? Their total revenue comes from the fact that they say how many sessions we have and how many dollars we're charging in this case. So I just want to write out an equation to represent that here. Just like an arbitrary equation right away, we say revenue is equal to, and in this case revenue, we'll even say it at the top here. Let revenue equal to Y. Revenue is equal to the price they charge times the amount of bookings they have, right? That should be fairly straightforward with these. But now what we want to do is pick out the data from these and see what's happening to each of these variables, the price and the quantity, when they change them. So off to the side here, we're going to say, well, they are initially charged a $10 session fee, but they're saying that they're going to change the price by $1 here. So what does that mean we have? For our price, that's equal to, if it was originally $10, and they say they're going to increase it by $1. Whoops, let's erase that. They say they're going to increase it by $1, but we don't know how many dollars, so we're just going to say that's an X value, because that's to be determined, right? And then the second component is we have 400 sessions, so we're talking about the quantity or the bookings. And that's going to be equal to, if they had 400 originally, they say that they're going to have a possible 20 fewer less for every $1 they raise. So we're going to say minus 20x. And do we see how those x's are tied? So they say that for every $1 we increase this by, or for every amount of dollars we increase this by, they're going to see 20 less bookings for each of those dollars. So the x values are actually combined together. Technically, they actually they mean different things independently within this equation, but they actually coincide, and we'll see why in this equation here. So if we know that our revenue is comprised of our price and quantity times by each other, let's say R is equal to the price, which was $10. But in this case, I'm just gonna, yeah, let's keep the units. $10 plus $1 X times our quantity, which was 400 minus the 20X. Okay, now we've set up our equation. We have our price, we have our bookings, but now we want to write a function to model this situation. So what do I have to do to make this a complete function at this point? Amy, what do I have to do to this? Foil it, yeah. So what's this going to look like once I foil it? Well, let's start with the first term. So if we know that foiling has to deal with this one, so we're going to multiply this one and this one. What are my first two terms?
Ignore the dollar.
Yeah, ignore the dollar sign. The dollar sign was just to make sure that we're talking about price here. Okay, 4,000s are, whoops, I'm going to make sure that's black color. Okay, so 4,000 is the first one. Okay, what's our next term? Negative 200 X. And then if we have to foil our next two terms here, what are our next two terms? Plus 400X and then minus 20X squared. Okay, now what can we do with this to simplify it just a little bit more? Yeah, let's add those two terms that are both x terms, right? So minus 200x and 400x can be combined. And what I'm going to do is actually just reorder this so it looks like a typical quadratic we've dealt with this whole time. So revenue is equal to negative 20x squared. What's negative 200 plus 400? What does that give us? Anthony, what is that going to give us? 200 positive x. Yes, exactly. Plus 200x, and then plus 4,000 on the end. Awesome. So now we have an equation that models this situation based on our prices and our bookings, right? So we can go to our next part. Everybody has this down, right? I'll take thumbs up if you have it down, or if you need more time, you can just let me know. You're all good? Okay. Whoops. I don't even know if it's on. Is it even one past that? Okay. What is the maximum revenue they can expect based on these estimates? So what I'm going to do is just rewrite out that revenue equation. So revenue is equal to negative 20x squared plus 200x plus 4,000. How do we get our maximum? Amelia, how do we get our maximum if we have an equation like this? What do we have to convert it to? What type of equation gives us our maximum?
I don't know the difference between the two, honestly.
Vertex.
Vertex form, exactly. Yes, David. Yeah, this is standard form how it is now. We need vertex form, and that's what's going to give us that maximum or minimum. In this case, because we know that our A is less than 0, we know we have the case scenario where our graph looks like this, so we have a maximum. So let's convert this to vertex form. Our first step is to say, let's factor out that 20, bracket, square bracket, round bracket, x squared. What's 20 off of 200? Negative 10, exactly. So we'll put negative 10x plus blank, bracket, minus blank, square bracket, plus 4,000. Okay, and then now we need that part that goes in the blank here. So we know our blank is going to be equal to negative 10 over 2 squared, because it's from that b value, is equal to negative 5 squared. And then what's negative 5 squared? Yes.
25.
Yeah, okay. 25. So now our it fills in to be negative 20 bracket. If we're going to form our perfect square here, we know it comes from the term that's attached to our squared. So this term right here. So we have x minus 5 squared. And then if we're going to say, what does our n term become if we're going to multiply a 20 to it? So we have the case scenario where we have a negative 20 times whatever was in that gap there, which is 25, plus 4,000. And then what does this part simplify to on the end? Christian, what does that simplify to?
3,500.
3,500. So x minus 5 squared plus 3,500, you said?
Yeah.
Awesome. So in this case, they asked for the maximum revenue. What part of this equation is the maximum revenue? Joy, where do I get the maximum revenue from this equation?
We get the maximum revenue from the Q, which is represented by 3,500.
Well, we actually know that if this is the equation for revenue, and we have it in vertex form, originally, I guess it's going to be kind of, let's see if we can go back here quickly. We said in the problem originally that let revenue equal to y. So our y-axis is our revenue. So if we know our maximum point from our vertex equation, then we know that that has to be equal to the maximum revenue, right? Because our vertex from this case is written as P and Q, which is 5 and 3,500. So we know our maximum revenue in this case is going to be $3,500. Does that make sense to everybody? Did I lose anybody? 2 thumbs up for good? Yes, Anna.
Wouldn't it be negative 20 times negative 25? Because there's a minus 25 on the end.
Yes. So now we have a positive. So what's our end value?
4,500.
Perfect. So now we have plus 4,500. And then just make sure this is squared. This term, now we just have to fix this with 4,500 and same with this one, 4,500 for both of those. And 4,500 there. Okay. Any questions now? That should look a lot better. Yeah, we have to make sure we put in our negative because there was a negative sign attached there. Is there anything else with that? No, just maximum revenue. If we wanted to, so let's say that I'm just going to create a hypothetical from the equation here. So let's say they said in the beginning, actually that's going to be part of the next one. I'm going to move on because the example I'm trying to make is a part of the next one. In this case, I'm going to get, are you guys okay with this? You have it all copied? Okay. In this next one, it says that a sporting goods store sells reusable sports water bottles for $8. At this price, the weekly sales are approximately 100 bottles. Research says that for every $2 increase in price, the manager can expect to sell 5 fewer water bottles. So right away, they want the same kind of thing. We're going to set it up such that our revenue is equal to our price times quantity. And let's let revenue equal to y. Okay, so what 2 things do I need to establish here? How am I going to set this up? Avery, do you know what we have to do with this? Well, we need P and Q, and so what information from the question here gives me that information?
I'm not sure.
And you can even just point it out in the equation or the question for me. What 2 things talk about price here?
The $8.
Yes.
$8.
Yes. Awesome. So we know that our price is equal to, well, they said they originally are $8. And then they say for every $2 increase. So we know it's going to be plus 2 times X where x is whatever value we increase it by. What about our quantity in this case, or the amount of bottles we sell? What is that going to be? Matt, what information from the problem here tells us the information we need for that?
100.
100, okay, yeah. And then is there any other part that tells us any information?
Oh, 5 viewers.
You got it. 5 fewer water bottles for that. So we know that if they originally are selling 100, and they say for every increase in the $2 price, or every $2 increase, they subtract 5 water bottles fewer. So now we have all the information we need to replug this back in. So if our price is 8 plus 2x, and our quantity is 100 minus 5x, well, now what do we have to do? What are we going to do to get it into our standard form equation? Yeah, I'll power through. Okay, so when we combine these, we're going to FOIL this. So we have our first two terms, 8 times 100, 8 times negative 5. So it becomes 800 minus 40x plus 200x minus 10x squared. We're going to do what we did on the last problem, combine our terms here. So, and then reorder as well. So I'm going to move the negative 10x to the front. Add these, which will give us plus 160x, and then plus 800 on the end. So that's the equation we're looking for. That's the situation, or that's the quadratic function that represents the situation. Next part says, determine the maximum revenue that the manager can get with these estimates. What price will give us the maximum revenue? So we know that revenue is equal to negative 10x squared plus 160x plus 800. If we complete the square, we have to take out the 10, put a square, a round bracket, x squared. If we take 10 off of the 160, we're going to get negative 16x plus bracket minus, and then plus 800. We know that our middle term there is going to be the blank is equal to negative 16 over 2 squared, which is equal to negative 8 squared, which is equal to 64. So we have negative 10x, we put whatever's in the bracket there, squared, and then it's going to be negative 10 times negative, well, we had 64 there, so it's going to be 64 here, plus 800. And so can someone tell me what this n part simplifies to in their calculator? N, x minus 8 squared, and then this one, just for the sake of time, I'm going to fill it in, but we get 1440. Okay, and then so the last thing is we know that the maximum revenue comes from the Q value, right? Because if this is in a revenue equation, then whatever on our vertex the Q value is, then our max revenue is equal to 14 with the dollar sign, 1440. But with this 8, it's actually, they say, what is the other thing we need to do? What is the maximum revenue, and what is the selling price that gives that maximum revenue? What is our selling price? Well, within the brackets here, what did X represent in this case? X represented how much we increased the price by, and how many bottles fewer we would sell multiplied by 5. So to get the price, we actually need to take whatever's within this brackets here and substitute it in for our price equation to get it. So we say that price is equal to $8 plus the $2 increase multiplied by, well, we know that our maximum occurs when it's at 8 units, right? Because our vertex is 8, 1440. Oh, I guess I can write it like that, but from this, our axis symmetry is similarly x is equal to 8. And we're actually just going to use that to sub in over here. So we get our price is equal to 8 plus 16, which is just equal to 32, 24, 24. So this unit only tells us how many units we increase it by for $2. So in this case, let's say the question said instead we want to see how many bottles. We would say, well, it's going to be 8 times the 5 and then subtract off the 100. But yeah, at that point, the vertex equation, you still need to plug that value back in. Unlike the last equation that told us what that was, that it was the width right away, we need to use this number in those equations we established. That was a loaded lesson, I know, but if you have lots of questions, make sure you stop by because these are tricky at the first. And you have lots of practice problems.